Assalamualaikum warahmatullahi wabarakatuh. So our group member consists of 5 people. The first one is Muhammad Shamir bin Muhammad Noor. Second one is Wele Gerald Julie. Third one Wasim Khan. Next Muhammad Helmi, and lastly one Akil Mukris. Assalamualaikum, my name is Muhammad Helmi and I will talk about introduction. So the general concept of this project: static equilibrium occurs when a particle is at rest or moves with constant velocity. Forces acting on the particle are balanced, resulting in no net force. For the key principle and force balance, based on Newton's first law of motion, an object at rest stays at rest, or in motion stays in motion, unless acted upon by an external force. Force balance: the vector sum of all forces equals to 0. Zero acceleration occurs even with multiple forces present if they cancel out.
Literature review. Introduction is the area of mechanics known as static studies bodies at rest or traveling at a steady speed. The equilibrium condition is when the sum of force is equal to 0. Next we have historical development, which is early theories, Newton's first law, and application of vector theories. Next one is formula and method. We have force decomposition, which is the resolving the force of x-axis, y-axis, and z-axis. And then method of resolving, FBD, and analytical and graphic solution. Next, the application. The application in static of particles, we have structural engineering, static of particle in rigid body, mechanics of materials, and equilibrium in mechanics system. Then we have modern research, which we have computational method and simulation, nonlinear statics and last deformation, particle system in fluid mechanics, and application in robotics. Lastly, we have the challenges, which is non-ideal system, dynamic interaction, multi-body interaction.
Assalamualaikum and good day everyone. My name is Wasim Khan, and today I'm going to explain about the problem definition of this question, which is the question asked about to determine the position of XY0 for fixing cable BA so that the resultant of the forces exerted on the pole is directed along its axis from B to 0 and has a magnitude of 1 kN. Also, what is the magnitude of force F3? The problem is troubled with the analysis of the forces on a pole supported by cable F1, F2, and F3. Goals are to determine the position of anchor point A of cable BA at the ground and the magnitude of the force F3 such that the system is in equilibrium. We need to find the position of the fixed point A, XY0, of a cable BA. The position of A must be such that from top of the pole B to the base 0. And our parameter is F1 equals to 500 Newton, F2 equals to 400 Newton, OB equals to 3 meter.
Let's dive into the detailed result of our calculation. Starting with the vector calculation, we determine the magnitude of the vector RBD to be 3.74 meters, calculated by using the coordinate of points B and D. Similarly, The magnitude of the vector RBC was found to be 3.61 meters, derived from the coordinate of point B and C. Moving on to the force components, the force FBC was resolved into components along the I and K directions, resulting in negative 277.0 I Newton and negative 415.5 K Newton, respectively. For the force FBD, the component were 107 I Newton and negative 213.9 J Newton. Lastly, for the K unit, which is negative 320.9 K Newton. Ensuring equilibrium, we verified that the total net force acting on the system is zero. This was achieved by balancing the forces along the x-axis, y-axis, and the z-axis, confirming that the system satisfied the equilibrium condition. Additionally, the calculated distances were determined as follows. The distance x is 1.94 meters and the distance y is 2.44 meters, calculated based on the given force equilibrium equations. Finally, the resultant force F3 was calculated to be 379.7 Newton, aligning with the directional vector from point B to point A. This detailed calculation confirms that all forces are balanced and the system in the state of equilibrium. The results of this calculation exercise highlight several key insights into force equilibrium and vector relationships. By calculating position vectors and their magnitudes, such as RBD equal to 3.74 and RBC equal to 3.61, we demonstrated how partial arrangement of points directly influence force distributions. Resolving forces into their x, y, and z components was critical in maintaining equilibrium, ensuring that the net force in each direction was zero. Furthermore, the calculation emphasized the importance of precision in determining unknown variables such as the force magnitude FBA, which is equal to 87.7 Newton, and its direction, which align with the vector BA. This result illustrates practical applications in engineering, particularly in designing stable structures and systems. Overall, this exercise bridges theoretical principle and real-world challenges, reinforcing how vector algebra and equilibrium concepts are fundamental in analyzing and solving mechanical problems. It also underlined the importance of meticulous calculations to ensure accurate results in scenarios like structural stability and force analysis.
In conclusion, a particle is in static equilibrium when all forces acting on it are balanced, resulting in zero net force and no acceleration in this state. The particle remains stationary or moves at a steady speed. Understanding static equilibrium is crucial in physics and engineering for analyzing force interaction and predicting object behavior. It ensures stability, safety, and efficiency in real-world applications like bridge, machinery, and structural design.